subject today, the agenda, what we really want to look into, this is how we'll be going forward. We'll start with the excuse me. We'll start with the introduction to cloud. Then we'll be looking into a little bit into virtualization because that's the basics. That's where cloud comes from, and that will also help you relate to cloud and virtualization. I was able to very quickly look onto your syllabus, and I saw that you have virtualization as a subject and cloud as well. So I'm sure those things would be relevant and would sound familiar to you. Then we'll move into the 5 pillars of cloud security. And trust me, every one of those pillars can be a complete session, can be a session for days, because it's a very vast subject, as I said. Then we'll be looking into the cloud security market and would give you a quick glimpse into what exactly is waiting for you guys ahead when you are into cloud domain or cloud security. And then few next steps, that how exactly we intend to go further and the future plans, what exactly I intend to do with IAMT or offer as a company to IAMT or the students at IAMT. So, cloud, what is it? And please don't hesitate to note down your questions. You can maybe ask me at the end, or don't hesitate to interrupt me if at all anyone would have any questions. So, the overall idea of cloud, where does it comes from? What exactly it is? A very quick search on Google will give you this Wikipedia page. So, overall, cloud is just something which has existed since a long time. It's just a new term that the marketing people use because they would have found it very attractive. Otherwise, if we go back to 1960s, 1970s, we used to have big mainframes computers. And these mainframes computers was not something was owned by every person using them. It was rented to people, and then there were different companies who were renting the services in there, and that was called mainframe redux. So instead of calling a mainframe redux, today we call it cloud. So cloud is all about just combining all those computing resources, whether it's storage, whether it's network, whether it's computing. They just combine it all together and then they sell it to you. That's all cloud is. So it's all about marketing. It's all about how better they can show it to the world and then sell it. So that's all about cloud. So it's kind of cloudy out there. Not everyone understands that, but it all comes down to that. It's just server sitting somewhere else in some data center and you're using those services. The the advantages of the cloud that's really into scalability and the performance, we'll be getting into that makes it unique, and that makes it as something which allows people to launch their companies infrastructure without thinking about the initial cost to different servers and all, and that's a huge advantage. And hence cloud today is gaining market attraction. And if anything good COVID has done, it hasn't done anything good though, but still, if we look into it, the evolution into cloud technology and the evolution acceptance of cloud has boomed to the sky. Like today, that's because of COVID that it has happened. Otherwise, what the day and the time we are in today, it would have taken at least another 5 to 10 years. But because of COVID, it happened in 1 year. And today we are there. Now, just to give you a quick infrastructure, NIST is a good reference model that you can also go check it out. There's a very good document from NIST on cloud reference infrastructure, and please don't hesitate to note it down if you don't have a piece of paper, maybe on your telephone. Few things that you can always go back and look onto. So this is how NIST divides the different cloud services and the different cloud infrastructure, starting from the cloud consumer, that's us who uses the cloud. Cloud auditor is the different enterprise, different entities who audit the cloud services, the independent entities who audit the cloud services to ensure that the privacy of the data in there, the different kind of security of the data in there. You might would have heard about PCI DSS, which is a rule of regulations which is used in payment industry. Then there's HIPAA, which is used in the United States for the medical industries. Recently, Reserve Bank of India have also came up with few regulations related to different data related to financial. So that kind of audits are done by these independent cloud auditors, and they give certification to these different cloud providers. Which brings to me, which brings me to the next topic, which is cloud provider. Cloud provider could be any company who's providing cloud services. Very well known are AWS, Azure, GCP, or IBM Cloud, or Oracle Cloud. These are the different cloud providers, but not the only ones. There are a lot more out there. And with the evolution that we are seeing today, and that's the point that we need to understand, that today the evolution that we are seeing in the market, there would be a lot of new cloud providers coming up. It's not going to just stick to Azure. It's not going to stick to AWS. It's not going to just stick to GCP. I'll give you a very quick example. Like when I started my company, we wanted to have an infrastructure. We wanted to have our things in the cloud because, again, that's easy, that's cost effective, that's scalable, that has good performance. So we were looking into getting some cloud services, and I started calculating the cost which would come by using AWS services or Azure services or GCP, all those known out there. And the price was, well, skyrocketing. I'll not get into the exact cost of it, but it was really high. It was highly priced, and that's the cloud service. And hence, what we did was we started looking for other services also. And then I ended up finding another cloud service out here in Germany, which is called Hetzner. And they are there for since several years. And one of my colleagues at SQR InfoSec, who is an ex-IIT Roorkee teacher and professor, he told me that they used to use it at IIT. So since I could find some history in it, I started using their services, and the prices were like half of what AWS was costing me. So you see the overall picture. What's happening is the customer, the client, when they start looking onto the price, which is always a big factor, they start moving to other cloud providers. And those cloud providers may not always be audited by these cloud auditor and always be secured in terms of how they handle your data. And that's where the cloud security comes in. And that's where this cloud security becomes much more important, and understanding the nitty-gritties of this cloud security becomes important. Finally, the cloud broker. We have a lot of cloud broker out there, which are like, they are trying to build their small systems on AWS and then provide you services. I'm sure you all would have heard about vTransfer. vTransfer is something that allows you to transfer files freely out there to anyone. That's a service which is hosted on AWS. So they're just using the AWS services to resell their own service. So they're kind of cloud broker who take AWS services and then resell it further. There are not a lot of them out there, but with the time and this evolution, that will happen more and more. Finally, the cloud carrier, that's our communication provider, the ISP, the internet service provider. It could be the telecom company, for example, Airtel. That's one of our cloud carrier because they are the ones who provide that means to access the cloud services. The different cloud characteristics which makes it important or which makes it beneficial to use. The very first one, the broad network access. Like today, anywhere, if you have internet, you can access cloud, you can access your services, which is hosted in the cloud. So that's the very first advantage. The second is the rapid elasticity, which allows you to scale your requirements like in matter of seconds. Like if you want another 10 servers, 100 servers, you don't need to wait for another supply of 100 servers or another 200 GB RAM or those RAM disks or the hard disk. We don't have to wait for all that. And just with a click of button, you have that elasticity, which is involved in cloud, which makes it attractive to use as well. Second is the measured service. Well, it's kind of a double-edged sword if you talk about measured service, because on our side, it could be at times beneficial also, because since we can, for example, we use our services just in the daytime, we can always turn off the service in the night and hence save the cost because the meter stops running. But at the same time, since it is metered, at times it becomes it becomes a little costly as well, because not everyone is following up on those. Not everyone had that kind of expertise to look into those costs and things like that. And that's where services like us comes into the picture, wherein with our expertise of cloud technologies and things like that, we help them understand what could be a better way of using a service wherein that would cost them much lesser than what they initially intended to do. Because today, just over here, we'll try to take an example. Today, what's happening is people think about cloud as if all they can do is go over there and run a virtual machine in there, which is like a computer in there, and then host everything on there, just like a regular server kind of mentality that we have had for several years. That we launch our server and then we'll put it on there. But now there is also serverless out there. Again, that's not the topic of this meeting. I'll not be covering serverless, but again, that's another thing that you should look into as well. Serverless is today helping a lot of companies to have a complete infrastructure without a server to manage. So you don't have to have your own VM or something like that. You have ready to use services wherein you can execute your code, run your functions, and run your different services related to API and things like that, and have all those services in the metered service or measured service. Then it's the on-demand self-service wherein you can provision the computing services as necessary. As I just said, the virtual machine, whenever you want, you can go log in and quickly launch one virtual machine, which takes approximately a couple of minutes or a minute to have your own server out there. Then finally, the resource pooling. Multi-tenancy is usually in place wherein a single physical machine is shared between different customers. And we'll be seeing that going forward, that how exactly that becomes one of a very big security concern because it is using multi-tenancy. Now, next, after talking about the different advantages, benefits of cloud, now we'll move into the different formats, the different delivery models of cloud, and explain to you. You must would have heard about SaaS, PaaS, IaaS. So just a quick definition: SaaS is an application hosted at the cloud service provider. Salesforce is an example. Office 365 is an example that it is hosted out there. All you go, you have to launch it, use it. So most of the infrastructure, the application behind it, the installation, the configuration, it's all maintained by the service provider. Like, for example, Office 365, though there are a lot of things in Office 365, but the very simple one that everyone understands is an email service. So behind that email service, definitely there's an Exchange server, which takes care of that mail server and on things like that. But that's all is managed by Microsoft. And hence, you don't have to do anything about it. You don't have to think about the security. You don't have to think about the performance. You don't have to think about the management. And hence, SaaS becomes a very attractive uses as a service, as a cloud service. Next is the PaaS. Now, I'll be honest over here. It took me years to understand what is PaaS. I was always confused. What is PaaS? Like, I always had confusion. I used to understand very well the SaaS and IaaS, but PaaS always was kind of cloudy for me, if you will. So what happens in PaaS is, I'm still like, even for today, I tried going through the definitions to make sure that I'd be able to give you a better way of understanding what is PaaS. PaaS is kind of where, like, at SaaS, you don't manage anything. Everything is managed by them. The application, behind the application, there is a server. Behind the server, there is a physical hardware. Everything is managed by the cloud provider. In PaaS, what happens is that the cloud provider handles the server, handles the operating system on which the software is installed. Now that software, which is installed on that operating system, is managed by you. Either you configure it, either you develop it, or you create your application. For example, I've put a couple of examples over there: Salesforce, Lightning, and Heroku. Heroku is one of the platforms out there where you can go ahead and do your PHP development, Java development, Ruby development, or different kind of databases that you can go ahead and host your own database or use the existing database. That's the PaaS, wherein they just give you the infrastructure on which you develop and you configure, but you don't really create that server. Now, talking about creating the server, that's where IaaS comes into picture. IaaS actually gives you the physical hardware, and now from there on, which you're creating your VMs or you're creating your servers. So everything is under your control, everything is managed by you, and there's also a dedicated tenant available where you can go above and beyond to avoid multi-tenancy. Now, to go above and beyond in multi-tenancy, we'll be talking about that in the virtualization topic, which will be further down in the slides. But having your own tenancy allows you to have your own dedicated hardware, wherein there is a specific hardware, a server, a RAM, a hard disk, which is dedicated to you out there in the data center of AWS, for example. So that those kind of possibilities are also there in infrastructure as a service. The very basic example, the one which everyone understands who have used AWS EC2 is those. It's one of those services where you can run your virtual machines in there or host your different servers. You can have your Windows virtual machine, Linux, Red Hat, or any one of those which you intend to. It's just those basic virtualization when you have the VMware, for example, you have all the resources available. Now it's all yours to launch your VM of choice. You can have your Windows, Windows 7, Windows 10, Windows 11, or Linux machines out there, and then test whatever you want to do on that. So that's the YaaS. The next topic that I wanted to get into was the different deployment models, like how exactly the different cloud services are deployed. There are three different kind of cloud services: public cloud, private cloud, and community cloud. To give you a quick introduction of what exactly they are, what exactly they represent, and actually four, there is also one hybrid. So public, which is offered openly, just like we just talked about Azure or AWS or GCP, like everyone can access, everyone with a credit card can access it or a debit card can access it. That's the public cloud. Private cloud is more of internally hosted in the organization, wherein they have their own application. They have, it's kind of going back to as we have had it always. But then what's new is over here, we are trying to use the concept of the cloud infrastructure, whether it is multi-tenancy, but I use this term, I'm using this term like multiple times, multi-tenancy. It's where on a single hardware, you have different resources hosted. It could be different VMs, it could be different services, it could be different servers or network services. So multi-tenancy. So an adoption of cloud way of doing things in the internal infrastructure is the private cloud deployment model. Hybrid is something which is happening today, actually. Like every company who is trying to go into the cloud, they are using hybrid cloud, wherein what they do is they will send part of their databases or part of their applications out there on the cloud, and rest of that they keep it internally, which is more crucial, more critical, which they don't want to expose on the cloud, which they are more concerned about losing data into. So they try to mix and match a little bit in the cloud, little bit on premise. And that's what the hybrid infrastructure is all about. Hybrid cloud is all about. And that's what's the adopted or used model in the today's world. And then finally, the community. The community model is specifically built for few groups. Now, to give you a very simple example, which will be very easier to understand, the community cloud is like, for example, AWS GOV. Like there is a specific cloud tenant which is created for US government. Then there are specific tenant which is created for military, or for those kind of purposes. The government asks for a different tenant, or a military asks for a different tenant, because as we've been talking about multi-tenancy, they cannot accept it to have it on the same hardware with someone else out there in the world. They want to have their own, and hence a complete infrastructure is launched for them itself. Like for example, the very last contract for US government of cloud services was won by Azure. So that was approximately a deal of $45 billion, something like that. So that's the grandiosity of it, that how big it is and how important it is. But then the community cloud comes down to that, a specific infrastructure created for a specific group who wants to have their own infrastructure privately held. Next, we'll be moving into virtualization, just to touch a little bit of basics and where exactly the cloud comes from, what's the basic infrastructure of cloud. So this is something, again, that's another topic that that took me some time to understand and learn that what exactly is these two different kind of virtualization, or the different type of virtualization available out there. So there's type 1, type 2. The type 1, the native bare metal, is the one wherein you would have seen the ESX servers on which there is a vSphere, and then directly all the different guest OS are hosted. Like over here, the hypervisor is our vSphere. It could be vSphere, it could be Microsoft Hyper-V, the different kind of virtualization platform out there. It could be Citrix, it could be Zen. So these are the hypervisor which are sitting there, and then they host the operating system directly. That's the one which is used in companies. That's the one which is used in cloud, for that matter. And then the type 2 is the one which we have learned virtualization on, or which we have used. It's our computer on which we have our own operating system. Then we install that VMware software, or a Microsoft Hyper-V software, and then host our operating system. So these are the two different kind of virtualization system out there. The one which is of interest, which we are more concerned about in cloud services, is type 1, where the bare metal hypervisor or bare metal virtualization is used. Now, virtualization is often, well, it's always, that's I should have changed it. It's not often, it's always used. The virtualization is the basics of it. But then why I wrote often over there, because now there is a new tendency. What's happening out there is we have also containerized infrastructure. There are a lot of application out there, a lot of SaaS model out there, the software as a service model or PaaS model out there, which is based out of containers. Like you have, like then there is another layer out here. Like after your guest OS, in the guest OS, you have another layer of containerization, wherein your system, wherein your application doesn't need an OS layer or hypervisor layer. It runs in an isolated fashion in the container itself. Now, virtualization, yes, that's true. Virtualization is not equal to simplicity, because there are a lot of stacks involved. There are a lot of different management stacks involved. There is a hypervisor, there's management platform, then there are virtual machines. You have virtual and physical networks to be managed. You have different storage to be managed, and everything needs to be managed on a different level with the same level of details and all that. And hence, that's not just one thing that you plug and play and it starts working. It's really a mix and match of a lot of different components, and any one of those components going down can just bring your whole infrastructure down, and hence it's really complicated out there. And then when we talk about the security perspective virtualization, then the patching, configuration management, making sure that we have a set template of respecting the different security best practices, or making sure that all the VMs that we have out there have a similar level of hardening. Hardening is more of securing a system with the best practices out there. It's like not activating certain ports, or not opening all the ports on there, or making it any kind of configuration that can make it vulnerable to attacks, or it can make it vulnerable to any kind of different data leakage, which can eventually be the result of those kind of missing patches or the configuration management out there. That was the infrastructure part of virtualization. The networking part of virtualization, when we look onto the cloud perspective of it, it's called virtual private cloud. I'm not sure if you guys have a little bit of networking background, but virtual private cloud is something like a VLAN. The overall purpose of virtual private cloud is to segment your network in different portions, or segment your whole infrastructure in different portions. So VPC is more of an isolated environment that leverages the hypervisor control, and it allows you to separate your infrastructure in different network zones. Like, to give you a very simple example, as we have learned about in the past, uh, when like in a company, when we talk about networks, there is different departments. There is sales, there's HR, there's marketing, there could be the admin, and all those departments are separated by different network boundaries or network perimeters, which is managed by VLAN internally, which allows to segment the network so that the people in HR cannot access the files which is in admin section, or the admin people cannot access the file which is in accounts department. So that allows to segment the network and make sure that the data belonging to one network or one department doesn't goes to another department or another network. And that's a similar concept in cloud, which is virtual private cloud, which allows to segment our cloud in different portions with proper networking schemes and all that, and make sure that we have that kind of segregation in place to prevent one part of the network to talk to another part of the network. AWS initially they started by EC2 Classic, which is like some 5, 6 years back, 10 years back, and now they have moved down to VPC. That's the overall concept that they're using. Even Azure, they used to have Azure Classic, which was less isolated, but now they're using Azure Virtual Network, which is like VPC, and that's what allows to segregate the network or segment the network between different portions. Excuse me. Okay, let's get into real stuff. Few vulnerabilities out there related to virtualization. I'm sure this might be Latin or Mandarin for people when we talk about codes like that, because it's really deep into security. But anyhow, I wanted to give you a quick overview of what's happening out there and how exactly virtualization as a concept or virtualization as a technology could be dangerous. The very first flaw which was found in VMware, or the virtualization software for that matter, not specifically VMware, but in the virtualization software, was VMSA 2009. It allowed code execution from VM guest into the host. Now, to give you a very brief idea of this, what exactly it looks like, it was found by Costa Korchinski, who found this flaw in VMware. So as we just mentioned, in the type 2 virtualization, wherein we have our own operating system, we launch a VMware, and then we set up VMs in there. So normally what's supposed to be that what happens in VM stays in VM, and it doesn't talks to the main system. Like, for example, if you have Windows 10 and you have a VM and then you have Ubuntu in your VM, your Ubuntu, everything that's happening in that Ubuntu OS shouldn't be talking or impacting what's happening in Windows 10. And that's the overall security that virtualization is supposed to provide. And that's what this code execution was found, wherein he was able to launch a calculator on the host machine from the VM machine, like from Ubuntu, by manipulating the code or doing manipulations. He was able to launch a calculator in the host machine. So that actually broke the segmentation which was between the host machine and the virtual machine, which was eventually fixed. And it was related to the VM display driver. You might would have got those pop-ups time and again when they say that you have to update your VMware tools. Those VMware tools is the interface between the host and the virtual machine. So that flaw was related to the VM display driver out there. Then the next one was the VM Escape, which was named as Venom. You can very well go ahead and read about it online. It was found by CrowdStrike. They have a lot of articles out there, which is very easy to understand. And this vulnerability, which was really critical, existed since 2004 until 2015. This was something which was, again, which allowed to override data from one VM and move to another VM. So this multi-tenancy that we are talking again, that we are repeating since the beginning of this presentation, multi-tenancy is on that hardware, you have different VMs, and those VMs are supposed to be isolated from one another. Let me show you this image. This will be much more clear. So you have this host system on which you have different VMs. You have marketing server VM, sales server VM, web server VM. Now, on this web server VM, there is this bad guy, there's this attacker who was able to overflow and move out by filling up the memory. We'll not get into the technical details of it, but somehow overfill the memory. When it was filled, it moved to another server or the VM hypervisor. And after moving to VM hypervisor, he was able to move to another VM. So if we try to look onto this step 1, step 2, and step 3, what we are looking onto is a cloud infrastructure. This is what cloud is, though it is something which was related to Venom. I got it from that time when it was related to virtual machine. But even on cloud, that's how it looks like. You have a hypervisor, you have the hardware, and it's shared between different customers. Like for example, marketing server VM, you can say that's Security Geek, my company. Sales server VM, it's the IAMT college server. Or web server VM, let's say that's some other company, the SQ InfoSec, which I have in India. So they have three different companies who have three different cloud services, and because of this flaw in there, the attacker was able to come out of this server, go to this server, and access the database of this server. So you see how this virtualization flaw and vulnerabilities that we have seen in the past impacts these kind of problems. And that's not something that have stopped. Like I would say in the last couple of years, example, if I'll tell you, like every couple of months or 3 months, we see a similar vulnerability that comes out. And then that is patched by different vendors or patched by the companies who are using VMs. And let's not doubt it that cloud infrastructure is not that easy to be patched, because over here we're just seeing three, but what usually happens is thousands of server on a single multi-tenancy model. So they cannot just go ahead and update their infrastructure or restart their infrastructure, because more often than not, when you update your infrastructure, you have to restart it. So more often than not, you don't do that very quickly. There is a proper change management which is followed. There is a proper rules in place. So every 6 months they update it. So there is always that time gap in which that infrastructure stayed vulnerable. And that's the reason why this kind of cloud security and the cloud auditor that we talked about and the different audits that cloud auditor does on the cloud providers needs to be consulted when you're working for a company, and then they go look out for a cloud service. AWS, Azure, GCP, they have well-known audit services out there. You can very easily find that. But then when you're working with other cloud providers, asking them questions relevant to this, that, okay, show me what kind of audits you have got, what kind of penetration testings you have done on your infrastructure, what kind of patching management, configuration management you have in place, how frequently you patch your VM servers. These kind of questions are very important to make sure that this kind of problem doesn't happens in our cloud infrastructure. The other one was related to Kemu, but again, you get the idea. That's how this virtualization has different impacts. Now, this one was also very interesting that I just wanted to quickly touch up on, though it's again related to virtualization, wherein what happens is an attacker, an attacker tries to fill the local hardware cache. As you very well know, RAM is nothing but cache. So the attacker tries to fill this hardware cache and overwrite all the data in that hardware cache. When it is overwriting that data in a hardware cache, remember that the same hardware is also used for another VM also. And after filling this hardware cache, it's able to simultaneously get the crypto keys, which are also stored in that hardware, because whenever the encryption happens, the encryption key is stored in the hardware, in the hardware module. So when it is able to fill that hardware cache, it is able to extract that encryption key also, which is the whole concept of this cloud. Like the only way your data is safe in the cloud is by that encryption, that even though someone gets access to your data, they won't be able to access it because it is encrypted by the keys used by the cloud provider. But then using this attack, which is kind of difficult to pull, it's not that easy, but it does shows the impact that can happen because of this kind of vulnerabilities out there into virtualization. And hence, very well enough, that's the reason we need to make sure that these kind of different patching, configuration management, different audits, different penetration testing done on the cloud service provider should always be checked upon and being asked that whether you are well audited, whether you are well confirmed with what the different security best practices are. In terms of hypervisor, though we haven't seen a lot of innovation, but lately, especially the big providers out there are doing some kind of little bit of innovation and advancement. For example, Amazon has gradually evolved from Zen paravirtualization. That was the basic that they used to have. Now they have developed their own hypervisor, which is AWS Nitro hypervisor. But then again, that's not something that every cloud provider is doing out there. As I said, that the evolution will make so that people will be going out to cloud service provider who are cheaper in cost. And trust me, that won't be AWS. And hence, when that happens, you need to make sure that that company is using the right hypervisor in place. What kind of hypervisor is there behind their cloud services? What kind of vulnerabilities is out there related to their hypervisor? Like, for example, the very best way of finding any vulnerabilities or checking out the vulnerabilities in any hypervisor, you can always just go and Google vulnerabilities in Zen Hypervisor. And there is a specific website, which is also from NIST or NVD database, which allows you to look into the different vulnerabilities which has been found. Like it's updated every day. So any latest vulnerabilities you can find out there. So if at all they're using a virtualization or hypervisor technology, which is kind of old, for example, Zen or KVM, for example, KVM is another one. Uh, that kind of hypervisor, which is kind of old in version, you can very well find out that there are vulnerabilities related to that and always challenge the cloud provider to make sure that they get it updated or use it as as a way to choose that cloud provider or not. Then on Google Cloud Platform also, they have their own custom KVM implementation. Azure, just to finish up the Microsoft part of it, Azure, they have their own Microsoft hypervisor, but they are someone who are very much open about their security practices and they always share what kind of security mechanism they have in place. And the hypervisor, like today, the most secured hypervisor that we have seen in the market based on the different tests, audits, and all that has been done is the one from Microsoft Azure, which is Hypervisor. Uh, Hyper-V, sorry. It's Hyper-V from Microsoft. Okay, so just to give you a quick overview of the different pillars of cloud security, that what are the different areas of cloud security that we work on, or me as a consultant, or our company as a service provider work on different topics. These are the 5 different pillars, 5 different subjects that we work on when we are working on cloud security. Very first, starting from cloud network security, uh, it's something that we have always had, but in a much different way. A regular traditional infrastructure used to be an IDS, IPS, firewall, used to have antiviruses, you used to have proxies and things like that. But now with cloud, you don't always have all those kind of technologies that is possible that you can implement in your cloud. Like for example, you need to have cloud compatible firewalls which can work with AWS infrastructure, Azure infrastructure. And now when we talk about firewalls, it again comes down to the same concept that we discussed earlier, which was virtual private cloud. This VPC is the first layer, which is the switching part of it. Like as we have seen in our networks, we have switch, we have routers and things like that. So the VPC is the switch, router, and all that. The firewall, which comes to the next level, is the front-facing infrastructure, which allows to protect our cloud infrastructure and have those firewall rules in place. Azure Firewall is something which is very recent. Microsoft came up with, and that allows to protect all your infrastructure by putting rules in place. You also have network access control, which is by default provided by different cloud providers, whether it is AWS, Azure. They give you that network access control that you can put rules in place and things like that, when you don't have to go get another firewall. Because when we talk about these cloud compatible firewalls, these are the firewalls which you go and buy, and then again, that's again a cloud model, a SaaS model, wherein they give you a firewall already deployed, ready to use, which you just connect with your infrastructure in cloud and set up all your rules. But at the same time, cloud also, the cloud providers, the CSP also give you the network access control where you can manage all these accesses. Then you have the different IPsec or SSL tunnels, because as we discussed earlier, the different cloud models that we had hybrid, we had public, we had private, we had community. So since we are more of into a hybrid model today, like 95% of the companies today use a hybrid model. So they have a connection between their on-premise infrastructure and the cloud infrastructure. For things like that, IPsec or SSL tunnels should be used, wherein there is a site-to-site VPN between the on-premise and the cloud infrastructure, no matter where that cloud infrastructure be or which cloud provider it be, because that kind of exchange of messages in an encrypted tunnel makes sure that all the data which is moving into the cloud is something which is protected in that tunnel and not visible to anyone else. Then you have web application firewalls, because today cloud, in a way, like one part it's virtualization, other part it's web. Like today when we say cloud security, it's web security. You need to better understand web security to also understand cloud security, because everything is API based, everything is web based. Those HTML5, HTML, that's what we are using to access these cloud services. And hence a web application firewall allows to protect our different application which is hosted in the cloud. And that's also a subject which is very much in demand today, because there are more and more applications which are launched in the cloud, but since it is exposed to the world, it is more exposed to different attacks, and hence a web application firewall has become a need of the moment. This is something which is not being used so much in the industry because it's kind of complicated. Not everyone understands how to use it, and to better understand how to use a web application firewall, you need to understand the different web technologies, whether it is HTML, whether it is PHP, whether it is the different communication patterns, or different API, or whether it is REST API, SOAP API, how exactly they are working. Those understandings are important to make sure that you understand web application firewall and be able to put that in place. And then finally, you need to also ensure availability in terms of cloud security, which is having backup networks. Like, for example, if one of your network goes down in the cloud infrastructure, you should have a backup network also, which allows you to access those services and make sure that your infrastructure doesn't goes down completely just because one of your network configuration went bad, and hence it got everything down, or all your infrastructure down. The second one is instance and image security. Now, this is something more of into the IaaS, when we have our virtual machines, we have our containers, we have different images that we use to launch those containers, or different VMs, or the VM images that we use. It's all about having the visibility of what's out there in the cloud. Like, you need to have a good inventory of the VMs, the templates, the container, the code repositories, the user accounts used, and these things allows you to better secure the overall posture management or security posture management, wherein you need to make sure that your VM is hardened enough, your VM has right amount of security, your templates that you're using, they have the right amount of security and configuration in place, or the container images that you're using, that they are not vulnerable, because after all, they're using an operating system in them, and those operating system could be outdated, they could have different kind of vulnerabilities, which can eventually create a hole in your infrastructure. So even though you have front facing things good and right, but then again, your image itself is not secured, that can eventually become a place of leakage of information. Like today, there are a lot of data leaks happening out there. There are a lot of attacks happening out there related to cloud. Cloud has become one of the biggest recipients, or biggest, how do you say, biggest destination of different attackers, that today they're all going there to go and check for these misconfigured services. Because what's happening is, with the evolution, and again, COVID has played a big role, but that's not all, and that's not like COVID has given birth to cloud. But then that's the best example that I can use here, that because of this, we've been pushed to go to cloud. Like, governments told us that you have to go e-commerce, you have to sell it online, you have to do things online. And hence, to do that, we don't have that kind of expertise in place. And today, we don't have that kind of cloud expertise in place. And that's the reason that becomes a scarce resource. But then companies cannot wait for the right resource, right person to come and help them. They just do what they can, and they try to get along with the limited amount of knowledge they have. And because of that, they end up creating security holes in their infrastructure, in their network, and then eventually that becomes the target of different attackers. Like, the very recent attack that happened was related to Indian Airlines, which was Air India. The Star Airways, the group membership of Star was exposed online, and they were able to steal all their data from Star and put it out there on the darknet. So that was related to cloud as well. The second one was related to Big Basket. wherein you might would have seen the advertisements, like it was long back, it was a couple of years back. Shah Rukh Khan used to come and show us that how you can order everything at your doorstep, all fruits, vegetables, and all that. The complete database of Big Basket was exposed online earlier this year, which was ready to use for anyone who have access to darknet. So it was all related to that kind of wrong configuration in the cloud, and hence those all data is exposed out there. Similarly, the other one was the very last example that I'll also give you was related to Capital One in the United States. Approximately some 500,000 users, all of their databases, their account balance, their social security number, their date of birth, their license IDs, their account passwords, IDs, everything was exposed. And they had to pay a fine to every customer involved, and that costed them millions. So that all happened just because of a wrong cloud configuration, which could have been taken care of just by someone who knew a little bit of how to configure it properly. So imagine a company or a bank like Capital One, which have a turnover of billions per year. They also have had this kind of incident because the talent is not out there. The people who know cloud security or who know cloud properly are not out there. And that's how your future in cloud could be much more brighter. And the need out there in the market, which we'll be talking in a future slide, is really high. We are almost there, another 5 or 6 slides. So if at all that's getting boring, we'll just get to the end of it and we'll get to the bonus part of it. But we are almost there. So the next one is identity and access management. With cloud, since our overall control on the infrastructure is going away, the only way or the very first step that we take towards security is identity. Like how exactly you protect your identity by doing multi-factor authentication. Whenever you log into your system, you have another dual factor, which is on your telephone, or Google Authenticator, or a Microsoft Authenticator, which allows you to have a multiple factor authentication. Then you have this federation of identities, on which I would like to talk a little bit with you guys. That today, when we talk about cloud security, federation of identity is a very important point, and that's something which everyone wants to do, and that's actually the best practice. Federation is using your local identities with a cloud service. So when we talk about local identities, traditionally the identities have been handled locally on Active Directory, LDAP servers, and things like that. So what it says is to connect your existing identity provider, which you have in-house, with the cloud identity provider. So that becomes the federation of identities. And that way, all your users are using the same identity, the same ID, and the same password in the cloud as well. And hence, they don't have 5 different passwords to manage. And hence, you don't find those passwords written on those sticky notes on the screens or behind their laptops or on their screens or on a notepad or things like that. And that's one of the very important aspect of security, like because today we have so many passwords to handle, we end up just putting them everywhere or using easy passwords, which eventually becomes a reason of attack or a vector of attack, how these attackers get into our network. The different federation of identities, then they use different languages. I'm sure you'll be covering that in your courses as well. So the SAML, which is security assertion markup language, then you have service provisioning markup language, which is SPML. Then you have extensible access control markup language. So these are the different languages which allows to communicate between your on-premise identity provider and the cloud identity provider. So that's the way of talking to them, just like HTML and all that. That's the different language to talk to web. This is the language to talk in terms of identity and exchange tokens, or those passwords or those password hashes with the cloud. Now, before moving to the next aspect of cloud security, this is a very good question that we should ask us again and again. Can cloud providers see your data? Now, this is not really a very relevant example related to cloud, but again, that will give you an idea. Today, when we're using WhatsApp, when we are using Telegram, when we are using different messaging platforms that we have out there, I'll not say Signal because Signal is encrypted. You are able to access at times your messages from a web browser and at the same time from a desktop software. Like for example, WhatsApp has a desktop software. Telegram has a desktop software. They have the web users, so you are able to access both from the web and from the desktop as well. Now, the thing is, if you're able to access it from the web and desktop as well, that means that the person, that the company who is giving you that service is also able to access that data. Usually, what is supposed to happen is that your password is there to decrypt the data, to make sure that the only person who can access it is you. That when you put your password, that data gets decrypted, and then you are able to access it. But when you are using it both the places, it's actually giving you access to the platform and not decrypting your data. That means that provider has an access to the data. And that's exactly what comes into picture when we're using cloud. Like today, that's a very big topic that we are trying to handle at BNP Paribas also, the bank that I am consulting as a cloud security architect over there. They have this very big concept, big problem that how to protect that data in the cloud, because they know that cloud vendors, whether it's AWS, Azure, GCP, they can see that data. Even though they say that they protect it and things like that, they're also a company like us. Like if our company can be attacked, if our company can be hacked, their company can be hacked as well. And when they are hacked, when their encryption keys are hacked or leaked, they can eventually get to the data and access all those confidential information. And hence, that's a very big topic today, which is related to data security. Because with cloud, what has happened is we have lost control. We don't have firewall. We don't have that perimeter of castle-like infrastructure. Like we used to say that the traditional infrastructure was more of a castle, just like we used to have in old times, that there were kings in the castle, they were top there in the mountains, and then when someone is coming, there was a big wall around their castle and they couldn't get in. But that's no more the case. Today, everything is out there in the cloud. There's no castle, there's no perimeter, there's nothing like that. So today, data security is something which is the only thing that we have, that we are sending it out there, but we want to make sure that that data that goes out there in the cloud is only accessible by us. No matter who takes it, who steals it, the data will not be accessible by them. Basically, they have their own encryption in place, the cloud providers, as I said, but at the same time, there is a second concept that comes into picture, which is called double key encryption, wherein what happens is once it is encrypted by the key which is provided by cloud provider, and then you use another key which is hosted at on your on-premise, you have your own hardware key management system, which generates another key which encrypts that data for a second time. And that way, even though your data is lost, stolen, or hacked, or leaked, that is not accessible by anyone but you. And hence that becomes to be a very important reason today, which is around data security. Now, that's just the encryption part, but when we talk about data security, there's also this visibility part. You might would have heard about data leak prevention, wherein the problem today is when we talk about the different cyber attacks, when we talk about the different vulnerabilities that we have out there, uh, it's not only the external people who are causing this damage. Even the internal people are making this happen just because they want maybe some extra cash, just because they are not happy with the services. And talking to the internal people, there's this very funny example I'll give you what happened recently, like what internal people do. Again, that's not related to an attack, but again, that's interesting to know. So I'll tell you. What happened was like some 2 or 3 years back, there's this guy at Microsoft support who was not kind of happy with a customer because he was not kind to him, or customer service, it's not always smooth as always. So he was not happy with that customer. And what he did was and he was about to leave the company, this Microsoft employee, he ended up deleting all his data and all that. And that was a company, like an enterprise customer. It was not just a client, like a regular user, like someone who using a Office 365 home license or anything. It was a company. And because of that anger, because of that dissatisfaction, he ended up deleting all the data which was there in his infrastructure, and that was eventually a huge loss for that client. And the Microsoft had to pay some kind of fine or something. And that was a US client. They also filed a complaint and all that. What happened was, like, now, like, it's been 7 months. This guy who did all that, he had his elder brother who lives in United States, and he planned to go visit him. to have some vacation out there on something. It was just like a few months back. He planned to go ahead and have a vacation out there. Soon as he arrived at the airport, you all know how good the US system is. He was caught by the FBI. Today he is in the jail after 3 years of doing all that. So that's a funny story, but again, that shows that the internal employees also can do damage. Like recently, you have seen about the Twitter problem also, that what happened, like the different big personalities started posting on their Twitter accounts that, okay, go ahead and send me some bitcoins, and I'll be more grateful, and things like that. And that happened because of an internal employee involved who was able to share the information, and hence this attacker was able to manipulate that person and eventually get into the Twitter accounts of these big personalities, that like it was also Mark Zuckerberg and different people like that they got into the accounts, and they were able to do different things. And hence an internal employee or disgruntled employee can also be a big factor, and that's why data leak prevention under data security is important, wherein we create different patterns of recognition, wherein when we say that, okay, if someone is sharing any data which is considered confidential for us, for example, for a bank, it could be credit card, it could be bank account numbers, it could be customer uh, phone numbers or customer details, or for a trading company, it could be the different stocks information. As soon as you see that in the pattern, which is created using regular expression, you need to just go ahead and create a data leak alert. So that's where the data security comes into place. Finally, the application security. This one I'll be just passing very quickly. Application security, it's all about having that code security, that the application that we are putting there in the cloud needs to be well coded, needs to be coded using the best practices out there. There are different services out there which is also provided by cloud service provider, which allows you to harden your code. AWS has their own code guru, which is based on machine learning, which scans your code and then tells you if your code is well coded or not. Then you have Microsoft Security Code Analysis, which has different kind of services in it. It has malware analysis. It has different kind of static code analysis, dynamic code analysis to find out different kind of vulnerabilities that could be there in the code. Then you have the GCP Web Security Scanner, which is based on OWASP Top 10, the web application security model. And since you guys also have web application subject, you might would want to go ahead and check some OWASP material. It's OWASP out there, which is really very important to understand, know, and have a good coding practice. And here I would like to share with you something sad and something very funny at the same time. Rugged software it's a movement that has been launched since 2010, as you can see, February 2010. It has been launched in February 2010, and it's a movement which talks about secure coding. And today, one thing that we all should understand, that all these cyber attacks happening out there, all this cloud security, cyber security, no matter what, all those things, the there are two big reasons. The first is users, because we are manipulated. We are made to do things which we don't want, clicking on bad software or entering our passwords at wrong places. That's one weak link. The second weak link, which is the most important, is the bad coding practice. Like today, the people who code the application don't know a thing about security. Like I'll give you a very simple example. Like I did my BTech over there in India in Bangalore, and there's this guy who was also from my school. He did his BTech somewhere in Agra, and he was one of those toppers at our class. He was one of those toppers. And after finishing his engineering, he got into software coding, software testing, and things like that. So very bright guy, and he's working for the last 11 or 12 years, just like me. And a couple of years back, he messaged me. He said that, "Hey, Adi, can you take out some 30 minutes of your time or an hour of your time and explain me how to add security to my coding practices?" So you see, a person coding from last 10 years, 11 years, considerably a topper of his class, never thought about security. And the other example that you see here is, see, Rug Software, which is the only movement out there who helps and gives different best practices. They have their own GitHub page where you can see the best practices of code security and all that. In 11 years, all they have is 710 followers. So even though we are working on it, We don't think about security, and that's a big loophole today, which is making this security, the different attacks and things like this happening. So that's sad, but that's something that we need, and that's something that we need to think about. Now, talking about some good stuffs. Why exactly cloud security? What's the landscape out there? Very recent article that I pulled up here related to 2021. Global cloud security market is estimated to be 34 billion in 2021 and is expected to reach 67 billion by 2026. That's a growth rate of approximately 14.2%. And all this cloud market is just a market. There are not enough people to handle or support that kind of growth out there. And that's the reason more the cloud services would be there, more the security concerns would come up. And hence more the need of people like us out there who are expert in cloud security, who understand cloud security would be accepted. Similarly, here it talks about the Indian companies. Indian companies are expected to spend more on information security and risk management in 2021. A chunk of that investment goes towards cloud security. So today, that's the need. Cloud security is something that they don't understand what to do about it. Like I'll tell you, like today, the bank that I'm working for, even though I have my experience, I had my interview with the head of the bank. He's the director for Globe for the worldwide. And he hired me for a big position, a big amount, a big contract. And all we had was he just said that, okay, I see you have good cloud experience. Tell me more about your past experiences and all that. He didn't ask me a question about cloud security. He didn't ask me what is application security. He didn't ask me what are the 5 cloud security pillars or things like that. And that's not his fault. The thing is, it's new. No one knows it. They just want someone to protect them, but they don't know who can protect us. And hence, there's a big lack of knowledge out there. And we need to prepare ourselves to fill that knowledge and fill that hole out there. I'll let you do that Google search. Just do cloud security market 2021, 2022, and you'll find it for yourself that what's the market out there, what kind of infrastructure, what kind of career perspective that you're looking onto, which you can eventually be part of and eventually gain experience with. Okay, so that's the end of it. As a few next steps, just wrote it very quickly. Focus on your course, get